Hi students, in the previous class we are discussing about second law of constant proportion and we have solved one problem. Let's see one more problem related to this. That's the second problem. Hydrogen and oxygen Okay, now they have given that hydrogen and oxygen combine together to form water in the ratio of 1:8, means hydrogen is 1, oxygen is 8. Okay, then what mass of oxygen would be required to react completely with 3 gram of hydrogen, they have asked. So here, if the mass of hydrogen is 1, then the mass of oxygen is 8. Then if the given hydrogen means it is 3 times the earlier one, then we have to multiply the mass of oxygen 3 times. Say, let's try that. So hydrogen and oxygen, the ratio they have given that 1:8. Okay, so hydrogen is 1 and oxygen is 8. So they are asking that 3 gram of hydrogen gas required. Say 1, we'll solve this here. 1 gram of hydrogen, 1 gram of hydrogen requires how much oxygen? So 8 gram of oxygen, means 1 gram of, in order to form water, 1 gram of hydrogen require 8 gram of oxygen. Then 3 gram of hydrogen requires, then 3 gram of hydrogen requires how much oxygen, that we have to find. So it is 8 into 3, it is 24 gram. So we have to write conclusion. So 3 gram of hydrogen, 3 gram of hydrogen requires 24 gram of oxygen. So this is a simple problem. Okay, so note on this one. So 1 gram required, hydrogen required 8 gram of oxygen. Similarly, 3 gram of hydrogen required 24 gram of oxygen. So in order to form water molecule. So this is about the second problem. So let's take some more problem. Just solve this problem. In an experiment, so this problem is related to the first two type, the first one. So solve yourself. So here the problem in an experiment 4.90 is a 4.90 gram of copper oxide was obtained from 3.92 gram of copper. In another experiment 4.55 gram of copper oxide gave on reduction 3.64 gram of copper. Show with the help of calculation that these figures verify law of constant proportion. So as we solved in the first case, the same thing you had to solve this problem. Okay, so there is no different method, it's the same method, just follow that and send me the answer what you get regarding this. Okay, let's see one more problem related to this. So try to solve this one also. When 3 gram of carbon is burnt, okay. So this is about another problem. When 3 gram of carbon dioxide is burnt in 8 gram of oxygen, it produces 11 gram of carbon dioxide. And what mass of carbon dioxide is formed when 3 gram of carbon is burnt in 50 gram? So and how much oxygen is burnt in 50 gram of oxygen, which law it obeys? So they ask. So here it is a tricky question. observe that something clue is given in this problem itself. Just observe it, the answer will be in 1 or 2 line. Okay, just try to find the answer and send me that. So these are the some of the problems related to second law of constant proportion. Now after this we will move to another concept, that is Dalton's atomic theory. So Dalton's atomic theory, it was proposed by a scientist called Dalton in 1808. In 1808, according to him, he says that whether any element or a compound or a mixture, they are all made up of smallest particles called atoms. So he said that once again, all the elements, whether it may be all the matters, in generally matter. Matter means either it may be a element or it may be a molecule, compound or a mixture, whatever that. So all of them, they are made up of very small particles called atoms. Then let's see what are the postulates. What are the postulates of this atomic theory? Let's see one by one. Postulates of atomic theory. So according to this, the first one is that all matter is made up of made up of the smallest particle called atoms. So what he says that every matter, they are made up of smallest particle called atoms, and these atoms are indivisible, they cannot be divided. So atoms are indivisible. That is they cannot be divided. So this is the second postulate. Then the third, it says that atoms then can neither be created nor be destroyed during chemical reaction. So atoms can neither be created nor destroyed. Can neither be created nor destroyed in a chemical reaction. So the atoms can neither be created nor be destroyed in a chemical reaction. Then atoms in a particular element, they shows all the same properties, means they are having same identical to one another one, means they have a same size, same mass and same property. So the next one is atoms of an element having, I can say are identical, that is they have same size, they have a same size, mass and chemical properties. Means if you take an element, say for example you take iron element is made up of iron atoms. So whatever the number of atoms they are present in the iron element, all of them having same size, same mass and same chemical properties. So similarly atoms of different elements, so opposite to this we have to write atoms of different elements have different size, mass and properties. Different size, mass and properties. So next one, so during chemical combination means while forming a chemical compound, the atoms combine with another atom to form, they combine with another atom in a whole number, means they are not going to combine in a proportion, they are going to combine in the whole number. So the next property, this is next passage says that during chemical combination, elements, atoms of different elements, different elements combined together as whole number, This is another postulate. Next, and here the number and kinds of atom in a compound are fixed. The last postulate is the number and kind of atoms. The number and kinds of atoms in a compound are fixed. So these are the postulates. See here, if you observe this, the two postulates say this one: all matter is made up of smallest particle called atoms, and atoms are indivisible. Okay. So here atoms can neither be created nor be destroyed. You see that this one, third one, atoms can neither be created nor be destroyed. So this Dalton's atomic theory, it is based on law of chemical combination. So the third postulate, as it says that it is neither be created nor be destroyed. So the same we have studied in law of conservation of mass. What it says that mass can neither be created nor be destroyed during chemical reaction. Similarly, here also atoms can neither be created nor be destroyed during a chemical reaction. So this postulate is mainly depending upon the first law of chemical composition, that is the law of conservation of mass. Then coming to seventh one, the number and kinds of atoms in a compound, they are fixed, and this postulates it is the second law of combination, that is law of constant proportion. In the law of constant proportion, what it says that, so here the elements in a compound while combining together, their proportion, the elements, the proportion are fixed. So here this postulates also means whatever the number of atoms are there in a particular compound, they are fixed. So these are the different postulates of atomic theory. So after all discussing about the postulates of atomic theory, now let's move on to what are the demerits of Dalton's atomic theory. So you can call demerits or drawbacks. Demerits, drawbacks, or you can use limitation. So let's see what are the limitations or drawbacks. So according to Dalton's atomic theory, the first one, he says that all the matter is made up of atoms and these atoms cannot be divided. But later it is come to know that even atoms can be divided into further as protons, electrons and neutrons. So hence the second part that we have studied, it will become the drawback. So let's write that one. So he said that atoms cannot be divided further, it was said by Dalton. But later it comes out atoms can be divided. Atoms can be divided further as protons, neutrons and electrons. This is the first postulate. Now let's see second one. Come to here. So atoms of an element, they are identical in their same size, mass and chemical property. You just observe this one. Same mass. Here after sometimes it is come to know that even atoms of the same element, they have different masses. So second demerits is atoms of same element have different masses. This is the second drawback. Then third one, so just fifth one. You see that atoms of different element have different size, mass and properties. Say this different mass. But it is come to know that even atoms of different elements, they have same mass. That is one more drawback. Atoms of different elements have same mass. This become another drawback. You see how we can say that atoms of same element have different masses and different elements have same mass. See here, there are some elements are there. So even in that their masses are different, and those elements having different masses. So it is called as, they are called as isotopes. They are nothing but isotopes. Here the same element having different masses, they are called isotopes. The reverse of that, atoms of different elements having same mass, okay, then they are called as isobars. Isotopes and isobars. So we are going to study about isotopes and isobars in the coming classes. So here these are the Dalton atomic theory. Once again we will just recall this. So what actually Dalton atomic theory said, that all the matter they are made up of smallest particle called atom, okay, and these atoms cannot be divided further, means they are indivisible. Then, so atoms of an element, they have same mass, size and properties. Like that, atoms of different element, they have different mass, size and chemical properties. And these atoms can neither be created, it cannot be destroyed during a chemical reaction. So among these postulate, that is atoms can neither be created nor be destroyed, it is extracted. It is the base of this postulate is the law of conservation of mass. Okay, similarly the another one, atoms of different element, the number and kinds of atoms in a compound, they are fixed. This law is mainly based on the second law of constant proportion, that is while combining a compound, the number of atoms, they are in the same proportion by mass. So this is about the postulates and demerits of Dalton's atomic theory. So here in the next coming classes, we are going to discuss about what is meant by atom and what is how to represent an atom and what are the different rules that we have to follow while choosing the name of a symbol of an atom, and what are the different types of symbols are there, what is meant by atomic mass, molecules, how atoms combine with together they form molecules, molecular mass, and there are some few problems are there related to this, and that we are going to discuss in the next coming classes. Okay, we shall continue in the next class. Thank you.